Okay, ladies and gentlemen, let's get started. We've got Pierre and myself today, Lewis McGibney and Pierre from the Semantic Technologies group, kind of heading things up here. And the entire purpose of this today is to try out what we hope is the first of many of these to come, which is, we've not called it simply just a kind of ontology experts, you know, working group, blah, 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 whatever. What we're trying to communicate today is that collectively the knowledge that we have in the Federation typically doesn't get encoded in usable and interoperable formats. I know that we try our best to do that. What we're trying to do here is specifically with a couple of resources, Suite, which is a suite of ontologies itself, representing a framework, as well as in Envo, the environment ontology. What we're trying to do today is demonstrate a contribution model which enables us to capture knowledge, encode it, and for you to be credited, for contributors to be credited in that fashion. So that's the workflow that we're trying to establish today. And I anticipate that we have more of these between now and in particular the winter meeting, in 2020 winter meeting. It's probably worth noting just now as well that there are ongoing efforts which pretty much reflect part of what we're trying to achieve today, and it's been going on. Ruth, Pierre can talk more to it than I can, but essentially in terms of gathering data, information, knowledge, and encoding that on a topic by topic basis. The current topic has been cryospheric science, but to capture that knowledge and demonstrate the workflow, and it's been working very, very well. So I think we can basically get going. Pierre, what do you have prepared here?
Yeah, sure. So I'll just do a little high-level introduction, just again, really what it's all about and why we're doing it in the first place. Many of you will know this. How many of you are actually Semantic Tech people or ontologists of some kind? So raise your hands high. All right, but we do have a mix of people in there who are from the outside, and that's actually what we're targeting here in particular. Just to show that everybody in the Federation can shape the semantic layer, even if you don't know how to code it, just by talking to us, letting us know what your knowledge is and what entities you care about, and then we'll do that modeling and worry about the interoperation. But then when you need to use a resource like Suite or Envo, you'll have something ready for you if you've put your knowledge on our queue, on our stack. And actually, the first half hour is just going to be an introduction to that. The second half hour, you can post what you want in there. And then the last half hour, we'll grab one or two of those and show how we add it to the semantic layer, so that at least you know what happens in the background. So it's a pretty relaxed session, but ask questions, lots of things are open. And as Lewis said, this builds on our Cryosphere work, so the Cryo Hackathon series that Ruth Duer, myself, and quite a number of others, Chuck included, have been contributing to. And that's really, once a month, we just link up remotely. We hack for about 2 or 3 hours, and we just align Envo and Suite concepts in the Cryosphere using Ruth's expertise and her work over the Global Cryosphere Watch's massive glossary comparison. So again, an expert driving and shaping the semantic layer with our expertise in ontology engineering, helping that happen. That's all. So we're just going to, do you have something?
Very quickly, just to state here, the amount of work to be done here is pretty significant. It's a large amount of work to do. We're not trying to tackle that anytime soon. We're just trying to take it step by step, very, very simple. What we're calling it is basically micro contributions. And what the benefit is that you get a micro
credit.
You get a micro credit, exactly. And we're going to demonstrate exactly how that works as well, folks.
Okay, right, so let's jump in. So again, really high level introduction. Ask questions on the way. Happy to slow down. I talk fast, and I've also drunk a lot of coffee, and I'm very jet lagged. So if you need me to slow down, I don't know, make some sort of symbol, throw something at me. If you're online, just say something. Right, okay, so let's jump in. So we all know what that is, right? What is that? Right, good. What's that? Yeah, that's the problem. So this is where semantic tech comes into play. Differences in terms of how people talk about, let's say, earth science entities, you'd be there in the biosphere, cryosphere, lithosphere. a single word like forest has many meanings. So to many, that's a planted forest. I mean, the regularity of the trees, so that's planted, managed differently, the biodiversity is very different. And so they're very different things in terms of environmental management, resources, sustainable development, you name it. But it's hard sometimes to identify that when I use the word forest in the US context, I mean something different from, let's say, Malaysia, when they use the word forest, or the FAO's official definition of forest, which we'll see here. So with all of those differences, and there was some research done by a researcher called Lund. Mark Schulthauer pointed me to this example way back when we started working on ontologies at NCEES, that there are thousands of official definitions of what a forest is, and there's a lot of lobbying going on to control those definitions. So when the FAO put together a kind of inclusive definition of forest, you'll notice there are lots of things in there that aren't forest at all by any measure, right? But again, they had to put it in there. I'd like to draw your attention to the rubberwood plantation in particular. That was the result of Malaysia lobbying the FAO to include rubberwood plantations as forests. I mean, they have higher biodiversity than palm oil plantations, but you know, a lot of people take exception to this. And there are some real issues with what you wrap up into that term. Again, Mark Schulthauer pointed me to this research some time ago, and I've been using it ever since, that definitions matter. They can really change analysis, they can change outcomes. Forests are one thing, but also some of the work that we do with UN Environment on the SDGs, when a country changes the definition of household, its poverty statistics look very different, right? So controlling definitions, controlling semantics, and being clear about what your data is about has really far-reaching consequences. Changing the threshold of canopy density, for example, can lead to very different pictures of the planet. So this is what we're trying to concern ourselves with here. We need to know what you and your expert communities in your contexts understand as, for example, a forest or a glacier or any of those things, because they're not consistent. And then when we move into a world of global data integration, we get problems, right? Right, I was just looking at the chat, just seeing how that's going. All right, so that's the issue, and that's what semantic tech is all about. It's cool, like technology side, and that's what we like. But it's also, the main purpose is to be clear about things, and the expert knowledge is the first order entity there. What you understand and the issues that you know. I know in the permafrost community that we work with Avi, there are papers getting rejected because they talk about permafrost regions and permafrost areas differently, and that doesn't jive with a lot of the stuff that we do in other kinds of spatial semantics. So what we try to do, we're agnostic to who is correct. If you're an expert community and you have a working definition and you have evidence to back it up, we're not going to tell you, we're not a standards organization. We're not going to tell you, no, you got to use this definition. What we try to do is coordinate the different definitions with semantic technology, give them different identifiers. We've heard about unique identifiers and web accessible identifiers. We give them different identifiers and we link them to show their commonalities and their differences, right? So that's our job. But what we don't have is what you have in your heads, expert knowledge over these different fields, right? So that's the whole idea. Once you get the right people around you or linked through hackathons or communities like ESIP, we need to transfer this knowledge, not in reports, but we need to put it into kind of a machine readable form. Yeah. Right, so that's the idea. And then once you do that, then different people with different systems can point to exactly what they mean on that knowledge map, if you will, right? Very loosely using terms here. So there we go. Let me skip over that. I just drew these figures. I had a sort of South Park ontology thing I attempted, it never worked. I'm glad it didn't work. Right, so the idea is that getting stuff out of your head into the semantic web, making them web accessible, so you can point to them. And we use these formats like OWL and RDF, which are very interesting. They're approachable once you jump in a little bit, but not the focus of this workshop. This workshop is about the knowledge, but that's how we get it out there with this web ontology language or the resource description framework. Right. That's it. And once it's out there, machines can start to process it. There's a whole bunch of technology that's been developed for decades about how machines can actually interface with that knowledge. It's never perfect, it's a bit lossy, but it gets us much closer to where we need to be and can coordinate very different people, policymakers and domain scientists and the public also. It's all open. All right, so in the sense you have this knowledge map, an ontology, where each node in that map or network is a clearly defined term. And then also the links between them are also clearly defined. So they're logically defined such that a machine can walk across that map knowing where it's going and knowing where not to go, where it's not allowed to go based on logical rules. Very importantly, every entity in that stack is web accessible. So every node and every link has its own URI or IRI, so a resource identifier on the web, and that's very important, so that a machine can, wherever the machine is, it doesn't have to load anything, it just follows that link, and it will know what the context is. So that's what it looks like. So rather than using a term like volcanic eruption, like a naked string, if you point to something like an ENVO term, which is volcanic eruption, or a suite term for volcanic eruption, it will be linked through logical links to stuff in other ontologies, like the chemical COEW, so that's the chemical entities of biological interest ontology. And the machine will know that it has those outputs, those chemicals. Meaning if you have a data set that's been annotated by those things, and you never necessarily declared that it was linked to volcanic eruptions, but it's annotated with those chemicals, and it's happening in a planetary crust, and it has an output that could be tephra. An ontology can help you infer that, hey, look, you're probably talking about a volcanic eruption purpose. Trivial example. Some of the stuff we do with the Cryosemantics working group and our cryo hackathons, handling things like the semantics of permafrost, so machines understand that. They understand that, look, it can contain rock or soil or sediment, not necessarily all three. It's cold, it's an environmental material, and it relates to other things in there too. And each one of those nodes, each one of those things like rock and soil, those expand out to other definitions and other terms that weave it all together, allowing machines to understand linkages in data and help people build applications that can get them closer to interoperation. So that's the goal of it all. So end game, you got your ideas in your head. You can be really precise. Different kinds of people can be really precise about what they exactly mean by pointing to one of those IRI defined terms. And they can, well, we're thinking about roughly the same thing. There's overlap, and you can point to those. And importantly, you can extend those. And that's what we're going to do in this workshop. Everything that you're going to put into the issue tracker, which you'll see soon, we'll be processing. And we're going to extend the semantic layer based on your knowledge so that we can be sure that it works for you and your applications or anyone developing technology around your application area. And then we can link all of the stuff to it, and amazing things can happen. If you want really cool demonstrations of that, you can look at DBpedia, and you can see how to really use Wikipedia, because they have a whole linked data semantic representation. And you can get all the cat pictures you want, linked to satellite data, whatever, right? It's possible, and it's great fun. We won't go into that there, but that's it. That's just a really mile-high definition of what we're about here. And what we're going to do next is have a little jam session where you can put in the things you care about into the Suite issue tracker. And then the last half hour, we'll show you what we do to that. So you get a feeling and this stuff doesn't look so obscure and esoteric anymore. Okay, so if you have any questions, just let me know now. Otherwise, Lewis will take it away and show how to put your knowledge into the fray.
Thanks, Pierre. Any questions, folks? Thanks, Pierre. By the way, okay, so we will be going through how we intend this to work, but I've also created a Google Doc if you're interested in capturing. Okay, this is for stuff that will not be directly on the issue tracker. This is just other notes. So if you navigate to the SCED record for this session, you'll see at the bottom of that there's a Google Docs link there. I've just split it into 3 sections. And what I would advise you to do if you're interested is, if you know a part of Suite which you would like to provide an annotation for, you would like to see enriched, or you just generally interested in maybe developing, please put your suggestions in there and put your name beside your suggestion, please, so that, if we don't cover everything today, then we can at least reach out to you and we'll try and engage you. Okay, so let me share my screen. Could you make me presenter, please, Zach? Thank you. Okay, excellent. If I share. Okay. Perfect. Okay, so
do you want the podium so you have both hands?
This is okay, that's fine, thanks. So what we have is under ESIP Federation, this is, I'm not going to take everything as basic as this. We do want to make progress, but I'm just going to skip through some things. And the ESIP Federation suite is available as, you know, a project nested there. If you navigate to the primary repository, we have a brief introduction to what it is, how essentially it's served as linked data, some other documentation here. Essentially, what I'm going to walk through just now is contributing, and I'm not going to take forever to do this. I just want to show you that if you're interested in making contributions, this is how it would be done. So if you look at development, you'll see that we've got a section, how to work with us in GitHub. Very quickly, just above this, we do have a policy, development policy here, which is reviewing prior to committing. We're not just committing stuff to suite willy-nilly, or that's not the intention anyway. We do have a community of reviewers which will review your contribution should you make one, and we intend to keep it that way. We don't want just any old stuff going in. So I don't really want to jump through all of this, but in essence, the first thing you would do is you create an issue. You create a local branch which is named after that issue. You make your changes, commit to that local branch, push to your remote repository, and then create a pull request. The pull request title is then named exactly after your issue with the issue description, title, and then you document what's going on. We will also say here, there's documentation for how to use this in different clients. For example, if you're using Windows. And then we've got kind of documentation as to, as somebody with write permissions for the repository, what you would do to merge and making sure that we can continue to develop. I will say something else as well, and this has been discovered by Brandon, who's online, and a few of us this week, is that the underlying OWL API, which is used in particular Protege, we have suspicion that there may be a bug in the version that's currently packaged with the most recent versions of Protege. And what it's doing is it's introducing this this error, essentially. And we didn't pick some of this up, so when we committed it, you know, it's content that we don't want in there. So what it indicates is that we need a bit more scrutiny in order to make sure this kind of stuff goes in. But anyway, what we have is an issue template. If you do go on to create, and this is essentially what it looks like. So say you wanted to create a new term label. This is a very simple comment or a description. We have the preferred term or label here. This is for adding, for example, a new term. We have e.g. explainer. We have a synonym if any are present. We have a textual definition, a suggested parent term, an attribution, which is an orc ID. That's all we would require in order to set you up with, to facilitate your contribution.
Can I interject there?
Yes, of course.
So again, with this workshop and generally, if you can't find any one of those things, don't let that stop you from putting your knowledge out there, from describing the phenomenon. We can find the parent term if you can't find it, or you just don't know how to work with that stack. That's okay. The main thing is that you just tell us about a phenomena you care about and link us to some of the resources where we can find that definition. We got a question from Chuck.
Yes.
Should I do that?
That's fine.
Okay.
So what about if users find a term that is very close to what they want, or they find a term that may have some issues with it? Do you want them to use the same template, or is there going to be a template to then help address, cleaning and these other sorts of issues that will come up along with new terms?
I would say, just describe it in the issue and we'll work on that one. I think that, this is actually more representative of the type of contributions we'll be seeing, to be honest with you. There's so much that's there that kind of needs a fixing rather than new stuff that needs to be added, in all honesty. So that is much more representative of what we're most likely going to be doing.
Yeah, if there's stuff that's not relevant to your request or you have a different request, just delete the template and describe the issue as best you can, and that's helpful. Yeah. Okay,
so moving on then. Once you provided, for example, an ORC ID, what does a micro credit look like? Well, we have this, which was provided by Simon. Essentially, we can populate your information in here, should you wish to do so, okay? This is pretty verbose. Say you want to, but you don't need to worry about this. See, this is the nice part. You want to provide this information, provide it. You want to provide just an ORC ID, an ORCID, then just do that, and we can credit that. But we're able to, if you did, in an example, Chuck, provide something brand new file, for example, you could be accredited as a creator or a contributor, depending on how a contribution would be made. But the point here is that we are interested in ensuring that any contributions that you make are credited. The other way, of course, that this works in GitHub is that when you look at the repository, should you make requests, then you're listed essentially as a contributor anyway. Okay, you can see Brandon and a few others members of the community have been kind of committing stuff. Okay, so are there any questions about this workflow? I think it seems to be working quite well. We've got it hammered down. We've got it nailed. Sorry, Pierre.
No, that's right. Just like if you're ready to go, then we can enter that half an hour.
Okay.
If you don't have any terms to enter, or you don't feel like you're a domain expert, but you have questions about the underlying code or how to work with the ontologies, we'll be here, and this is an unstructured time. Just call Lewis, myself, or others on the Semantic Tech committee, and we can certainly answer any questions you have. Right. So, and then in the meantime, please do submit, because we're going to choose one of those issues that's out there and work that up. So think of an interesting, strange request that you could imagine. We have some really interesting examples coming in, very unpleasant things sometimes, but that's okay. So if your imagination can take you where Yeah, Chuck. So Chuck's asking for a prize, and this, I should have predicted this,
no joke.
But I didn't. Yeah.
Okay.
There could be.
We'll sort something out. We'll sort something out.
Depends how creative it is.
I was going to say we'll buy you some drinks tonight, but based on last night's performance, I don't think that will be happening. All right.
All right. So go for it. Yeah.
Okay.
Oh, sorry. We have a question down there.
Yes.
Okay. So I'm not familiar with working with ontologies and stuff. And so one of the things that I looked at in fact, I was looking in at suiteontology.net, and running down through there at a term that I was wondering about and looking at the source here and things like that. And I don't ever find the spot where there's an actual definition of where the leaf is in all this. It's like I see all the branches. So in particular, it was like, I see where it says, well, cold front is a front, is a kind of front, everything. But then there's nothing that says, and this is what a cold front is. Where does that go? Why can't I ever seem to find that when I do look for it?
It's actually an excellent question. So, I mean, you can consider suite as more or less abstractions on a lot of concepts, and suite should be considered in that way and used as some sort of a framework where for your knowledge application, typically you would extend. You would utilize suite for understanding maybe the domain range property, these types of things, but not for the concrete knowledge source. Is that fair to say?
That's fair to say, and that's where we complement it with this with ontologies from the biomedical world, who's been doing this for like 20-30 years.
Right.
And that's where we're going to encode the definitions, the meanings, and all of these fine-grained relationships. You'll see that once you post it. So be as descriptive as possible, because that description is going to go into that more expressive ontology, and then we map it back to the suite framework, so it's interoperable. And so suite can do its job of having this framework, and then we complement that with OBO technology for the real expert expression.
Right, and also considering the best way for us to move forward. I have a stronger feeling now that this is appropriate than I did, a while back. I think the most appropriate way for us to move forward with suite is obviously to crowdsource, how this works, but in particular, if you feel that anything that is currently encoded in Suite is well defined in some other location, regardless of where it is, then include that in a contribution, because if we have even a string, a textual definition, we could link to that. And this is the type of stuff that we're trying to do. We're not trying to reinvent definitions for things. We're trying to utilize existing knowledge sources where available and make sure that, we're adequately linking to those. Vardis.
So I'm kind of totally new to this area. Is there some kind of concrete connection between, for example, the CF standard names and the units and all of that to the Suite ontology or vocabularies that are associated with the Suite ontologies?
There are units of measurement, and it's units of measurement in particular. Standard names. In all honesty, right now, no. To be honest with you, no. There would be I do think that, so there's no current mapping, right? There's no link right now. That's pending work. Okay.
I think the mapping is hard because there are multiple concepts embedded in a CF standard name that might be all over the place in the ontology. So do you have is there a plan for doing that? Because it would be an interesting exercise to try to figure out how to do a mapping.
There's actually a RDA parameter working group, working with multiple vocabularies to figure out how to do that systematically, because also those, and like CF names often are dependent on some methodologies. So it's a real semantic challenge, but many people are asking for it. And that's something even on the issue tracker, if you think there's urgency, put it in there and say, hey, look, this is something that would really amplify our usage.
So Beth can go. Yeah,
Okay,
I was really sure there was a CF.
Sorry, could you introduce yourself so that online?
Thank you. Yeah. I'm John Grabio, and I had things to do with some of these things. So including the community ontology repository. I'm at Stanford University. The thing that confused me was I think I understood you say there was no CF to Suite mapping. And in my head, I'm really, really sure there was, but so I'm trying to find it now. Is it possible there was and it's gone away, or?
Well, it's possible. I mean,
I'll look it up. It's not critical.
There were a few attempts, and it's often automated mapping, right?
Yeah.
Sometimes that needs curation because we're not when it's automated mapping between two resources and vocabularies, we're reluctant to sort of just release that because we don't know if it's accurate.
Yeah.
Unfortunately, when you're doing semantic stuff, it does take some human curation to be sure. Otherwise, stuff can get kind of funky. And learning from the biomedical community and biological community, there was a stage where ontologies, the use became clear. Everybody started developing ontologies really quickly, and the quality dropped. Then the whole community lost faith in it, and it took some years to rebuild that. We want to avoid it with the earth science community.
Right. Yeah. No, I think the one Suite mapping there was one that Rob Raskin did, and that's a while ago now, so maybe not so relevant. But.
Thanks, John. Seconds, please. Beth.
Well, I'm interested in whether or not the semantic sensor network ontology could serve as a mapping mechanism for CF names, because I don't know if people are familiar with the CSDMS standard names, that, he's got a really precise syntax that he uses and set of rules for constructing names, such that you have the measurement medium, the feature of interest or the measurement object, the quantity, and then you can put in different kinds of modifiers. And it might be really interesting to try to map, CF names are a little messier than that, but to try to map the parts of it, because you've got something like, aerosol optical depth due to black carbon particulate matter at blah, blah, blah. And you'd need to break it up, I think, in terms of some of those kinds of concepts to do a mapping that made any sense, but it might be an interesting thing to think about.
Again, that RDA working group on parameter semantics is where this is happening and these discussions are happening, but it's looking at a number of them. I'm not sure if I think SSN is represented. It's certainly part of some of the other.
Well, I mean, I'm involved and I was involved in SSN, and so I mean, absolutely, Beth. you know, if this kind of idea is heading in the right direction, I mean, what I would say is, you know, we've been trying this over a number of years. What you get from SSN is a vocabulary which expresses some of the relationships which are needed in order to achieve what you're talking about there. But then there's still a degree of complexity in the description of things like the type of the feature of interest and the observable property, and that which it needs further elaboration, which is not provided and deliberately and explicitly not provided in SOSA and SSN. So SOSA SSN is really, it just provides you the predicates to link the elements of an observation to the things which it wants to refer to, and then there's additional structure needed, and that structure is certainly exposed in CF names. Another big vocabulary that I'm aware of is from the oceanography community, the NERC vocabulary service, the P01 vocabulary is hilarious. You know, there's 50,000 terms in there, which are largely because it's a combinatorial thing based on the other things, but the rules for how those combinations are derived is very much the space in which we're thinking, you know, we need to think about it.
Now, as you're hearing this, if you're not into the Onto space and this sounds like esoteric to you, the takeaway is that there are people working on aligning all of these things in the background. But again, unless we need at the same time knowledge to flow in from the expert community in this kind of issue tracker sort of way, so that we have the material to focus that work on. Because if we know a domain expert has asked for this, we know that that's a priority to get it into the semantic layer. And then we do this sort of semantic fussing, and there's a real drive to make this work because we realize that we all have to chip in from different ways and collaborate. Yeah, so please continue. Sorry, just an interjection there because we're getting a bit into the weeds. But you know, if you can't participate in that, please just post your issues, things you care about, interesting phenomena, environments, entities, geospatial entities. Go for it.
All right. What I was going to suggest is that if you have your favorite CF variables, like these 12 there, that would be a good thing to note because nobody's going to be able to do all of it at once. But certainly somebody could do one or two, maybe even today.
You know, trying to align to large, like for example, you know, why don't we align suite with GCMD keywords? But you know, that's never going to happen in one step. There's just absolutely no way it's ever going to happen. What we're talking about here is the micro contributions and actually paying enough attention and scrutinizing the micro contributions is, I think, where we want to be moving forward.
Yeah, and I just wanted to comment on the whole feature of interest, that it's not just this community that is actually using that keyword. So as part of the drone hackathon that we did 2 days ago, we identified that there's a ontology that BMW is actually developing that's a vehicle sensor ontology and vocabulary, and it is subclassing both geo feature and SOSA feature of interest, right? And so you have these cases where, you know, an engine, right, is actually a feature of interest, right? And so you have, you know, people that are then able to pick up on that stub and be able to extend it for their own purposes, right? So
I wonder if it's worthwhile as just, are there any other questions? I wonder if it's worthwhile as just now showing like what an alignment kind of looks like, because an alignment does exist, and then we can go on to crowdsourcing these definitions, right? For example, am I still sharing my screen? Yes, okay, excellent. For example, if you go into the suite source, you'll see an alignments directory. And within the alignments directory, you'll see that we have an existing alignment to DCAT and an existing alignment to SSN, okay? This particular alignment to SSN was generated by Simon. And what essentially you can see, it's in turtle syntax, but what you can essentially see are the vocabularies which are being used, reused, the namespaces. We then have the concept which you're trying to create, which is the alignment. This is the, you're saying it's, you know, you're telling people what it is. This is the micro accreditation. We're stating what this alignment relies on, providing the imports required in order to make the correct alignments. And we have versioning. We then get down into the kind of details of what the alignment actually is, where we're stating that the suite observation is a subclass of SOSA observation, that the suite result is a subclass of SOSA result, and so forth, okay? So we do have examples of how this type of stuff is working. And I also want to just show, because we're kind of here for the time being, I also would like to show another mechanism we've used for automating part of alignment. So I put together this alignment manager, which itself utilizes another tool to align to various targets. And for example, what are those targets? Well, there's the Australian data set, Ontology. We've aligned to DBpedia. These are GCMDRDF representations of instruments. Ontosoft, which Colin at the code registry, they utilize Ontosoft to actually describe software which is in that repository. And a whole bunch of other stuff, right? SOSA, SSN, blah, 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 blah. Prov. And what we end up with is a proposed alignment. So for example, if we were to take, let's just take SSN here. It spits out an RDF, well, an XML document which attempts to align entities, and it gives you a measure of confidence for that alignment. So for example, we have the mathematical has input and SSN has input. We're stating that there's an equivalence, proposed equivalence of 1.0 here. A high score between 0 and 1 indicates that it should be a strong alignment. And then what you can do is simply encode that, submit it as a contribution, and then we review the alignment, and then this is how you would potentially make a contribution. So this is just kind of some tooling that we have for this stuff as well. Okay, I think that's enough of this.
We have about 20 minutes, right? So we have about 20 minutes for issue gathering. I see a couple only. Don't be shy. Just put it in there.
Very good.
Again, anything that you're working on or you care about, an atmospheric part, a deep sea system, hydrothermal events, whatever you're working on and whatever you care about.
Yep. Just
put it in there and put in a definition, and we'll work it up. You know, it doesn't have to be great. This is just for the demonstration purposes. That's clear.
Yes. What it looks like.
What it looks like. Yeah,
absolutely.
Sure. Yeah.
Absolutely. John.
I was going to ask a question about how to understand what I'm looking at. So I was starting to just look through an example of suite and some of the terms, and I found human, and then I found space heating and space cooling underneath human. There are no definitions. I can think of 2 or 3 ways maybe there's a meaning, a link between those. Can you just describe whether there's any implication associated with the hierarchies in suite, so we know how to phrase our question as opposed to what the heck is this?
I mean, I would recommend just, if you have that revision, just note the problem, because again, suite is a huge thing. It was when Rob put it together, he did an immense job, and at the same time, some of the semantics, I guess the community wasn't aware of like semantic conventions at the time. I'm not sure.
Okay.
But whenever you spot that, just let us know about it.
Okay.
And we'll figure it out. And this is where the oboe semantic, let's say, best practices are coming in to help sort out these issues.
Yeah. Okay.
But when you identify it, and if it hurts your work, let us know. Like, okay, this is potentially going to confuse a lot of my work. Please clean it up. And then we have a priority target to fix.
Okay.
And we'll figure it out.
And I did find with a search that the most recent mapping between CF and Suite was Rob Raskin's done with the 2.1 version of Suite. So it may still have some usefulness for whoever was asking that question.
Thanks, John. Yes, I think we should do an example, folks. Okay, so what we have here, 7 minutes ago, Adam Answer. Who is Adam Answer? Is Adam Answer in the room? Excellent. Okay, we've got Adam Answer up the back there. Adam has, it looks correctly, and we've got a thumbs up, correctly identified the fact that pyrozine, is it pyro?
Pyroxene.
Pyroxene.
Mm-hmm. Don't drink it.
Don't drink it. Is spelled incorrectly, okay? And we have an attribution here. So what I think we could probably do here is go through the process of.
Well, I think the question is how to add the issues in the first place, right, Zach? Right.
Okay,
sorry. Not the resolution.
My fault.
Yeah, not the resolution.
My fault. Okay. Issues.
Yeah. So let's create a new one.
Issues. New issue.
Let's add a class like termite mound or something.
Okay.
Yeah, post one. Think of something interesting, Kai. It's almost there.
Okay, thank you.
So Kai will post one, but that's how it is. You just post a new issue.
Okay.
You follow the prompts on the screen, fill that out.
So this is automated for you. The guidance is automated, where you can see. Fantastic. Thanks, Kai. Okay. So we're going back, but you can see how this would work with a new issue. We've got a new issue template. Describe essentially what you want to try and do, Andrea. Describe what you want to try and do. You know, what I would say, Adam, about that message is, I don't know how pyroxene should be spelled. Okay, can you create a pull request? No problem, no bother. Yeah.
What is the easiest way to see if a term or class is already in there?
The easiest way I would say is probably to navigate. Well, I mean, you can use GitHub search, right, for starters.
Yeah. Yeah. I'll demonstrate that here.
Yes, please do. Right. So if you like, for example, scroll up, or Pierre. Yes, please. Just a general search. So the search bar for GitHub now enables you to search on the repository itself. So your search will not go outside the repository in this repository. Okay. So, you know, this is not type ahead. It doesn't give you suggestions about what's there right now. But again, you know, I personally wouldn't contribute anything to Suite that I didn't really know about. I'm not looking to contribute to things I don't have a clue about. We're looking to gather expert knowledge from across the community here. That's what we're trying to do.
Yeah,
I mean, for example, with the variables, Beth had provided an example of, you know, atmospheric pressure at blah, 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 blah. I would never make a contribution to try and align that because I don't have a clue about it. We're really looking to try and find suggestions and to gather that knowledge that you're experts on. Pyroxene is a perfect example. I had never even heard of pyroxene. So there's no way I would ever make a contribution on that level.
And also keep in mind, a lot of the stuff in Suite is not defined. So don't worry about it too much. Right. You don't even have to look for it. If you have a definition, that's great material for us to work with.
But I think another thing that I would maybe like to do at this point is just show a graphic, which I think potentially helps kind of show the core parts of what Suite is. And we grab this. This might have actually been, it might have actually been generated by Rob under graphics. Sorry, I was going to bring that up.
Question. I was just wondering, are you envisioning actually ever having definitions in Suite or just maintaining it as a word net?
That's exactly what we're trying to do. This is exactly what we're trying to do right now. That's exactly what we're doing right now. That's exactly what we're trying to do right now.
Yeah, so for your guidance on the issue tracker, Kai just posted an issue about oxygen minimum zones. And that's more or less what we're looking for. Something that's relevant to your work, check it out. If there are any synonyms, you can put it in there. And if you can find a definition, even if it's a Wikipedia definition, just a place to start, that's fine. But again, if you have your own knowledge with your own ORCID in there, it lets us know that hey, look, somebody who works in that field or knows a lot about something has given that. That doesn't mean it's going to be set in stone. It can be revised when other people say, well, we think it should be changed, and it's all version controlled, etc. And we have ways of making sure that if the meaning of the class is changed, we'll have a different IRI for a different meaning, so that your old legacy annotations are not then changed. The meaning doesn't change in previous annotations when the definitions may change over time. We'd create a new class, right? So, don't be shy, try it out. Does anybody else need any more guidance, or you can just raise your hand, we can come to you, we can help you post stuff. But yeah, don't be shy.
On the screen just now, folks, you can see the core parts of the framework, and everything builds off of these concepts of representation, of microscale processes, of macroscale phenomena, matter, realms. So this is an excellent place for a lot of people to start, I think, in this particular community, where you're an expert in some part. Perfect example is Cryosphere. Ruth, Chuck, Pierre have addressed that and have made a lot of progress in that field. It could be anything. Human activities, observations, properties, state, and relations between. So this is really where you will see the files are named after these foundational principles as well. That will be prop something, state something, relation something, right? Realm something. That's how the files are named after this logic as well. Okay, so let's take an example. I think Kai had posted. Excellent. Did you create a pull request by any chance? No problem, that's fine. No bother. Oxygen minimum zone, so here we go. Thank you, by the way, folks, for registering these. Preferred term label, oxygen minimum zone, or marine oxygen minimum zone, or marine. Synonyms, thank you. A textual definition from the Wikipedia page, perfect. One of the things that we're thinking about doing here, and I'll bring this up, is utilizing essentially DBpedia for achieving this, more or less this exact thing, and I'll show you. It's oxygen. Oops. Let's see if we have this. Okay, we do. So the page, as expected, the resource, I should say, exists within DBpedia. This is the landing page, and essentially what we would be doing is grabbing this English comment and encoding that or linking to that. But as Kai has proposed, we have the textual definition, and then we have his ORCID. Mm-hmm. From this paper, microbial ecology for expanding ocean, oxygen minimum zones, they give another definition. Typically what we would do at this point is we would hash out which definition we think is potentially more appropriate, and then that would be encoded into an RDFS comment to accompany the new term and the synonym.
And then I think that's the key point of differentiation. DBpedia is sourced from that whole community, like everybody who's contributing to like Wikipedia and others. So the suite collection of ontologies has the opportunity to source from real domain experts, to have it much more high quality with identified working groups of people that are taking care of those subjects. This includes things like the Cryosphere under Ruth. We know that there's somebody who did some work to harmonize these definitions, or at least gave us links to papers or documents that they trust. And that level of trust is important for us to build expert-driven semantic technologies. Okay, so what's our time? So we have 10 minutes more, and the good examples are rolling in. Please keep going, and we can then select one, and we'll show how we then integrate that into an ontology like Envo and map it back to Suite.
Okay. Here we go.
Thanks. So in this particular example for the oxygen minimum zone, that refers to the water column properties of the ocean. But you can also have anoxic layers in the sediment. So I'm just wondering how these concepts would be related in this graph type.
Yeah, maybe that's a good example to actually show how we would do that, because that's a case where a syntactic label, can be ambiguous semantically. And in a brief preview, we'd encode it. Maybe we'd give it a bit more of a verbose label, like oceanic or marine oxygen minimum zone, as Kai suggested there. Yeah. That would be the first order. And we'd also identify that there's a broad synonym of oxygen minimum zone. And if there are others that are identified, sedimentary, etc., we can add those as separate classes, link them to the class for sediment, right? So it knows it happens inside the sediment, and move on from there.
I mean, I would mention what to summarize what you've proposed there, Pierre, is essentially an engineering operation. There's some of this stuff is very easy, like spelling mistakes, and some of it's absolutely not. And you've just highlighted that there, Vardis. So thanks. And by the way, I came across, I was looking, Brandon and I were talking, Brandon's online, and I were communicating at the beginning of the week. And as it turns out, I believe Suite was developed, and a lot of the current content reflects this. It was developed prior to some of the vocabularies which are richer for describing basically things, properties, whatever. And because of that, what we have is subclass of an equivalence class used to make relationships. And a lot of equivalencies are not actual true equivalencies. So what we're finding is that we'll gradually be going through that and changing equivalence class to some other relation which more accurately reflects how, or the degree of equivalence, or the degree of similarity. Yeah. Okay. Okay. By the way, folks, we are proposing to run a workshop at the forthcoming AGU fall meeting. We're potentially also going to be submitting something, and I know it's quite late, but potentially submitting something to the Ocean OBS, which is coming up in San Diego, Hawaii. So we'll maybe try and do a remote session. Ocean Sciences meeting, sorry. In
February, right?
In February, yeah. In San Diego. So potentially we'll be doing something there as well. But if the workshop for AGU is approved, then we will have I believe a half-day workshop to try this out again.
Right. And at Ocean OBS, there's a small group of us, Adam Shepard, myself, and some people from the NERC, so the UK, the Brits, the NERC vocabulary service for marine vocabularies, figuring out how to map it all together. So then you as a user, if you're part of that, if you're using any one of those vocabularies that are making efforts to interoperate, then it doesn't at the end matter which one you use, because they can talk to each other. And if you need to use one with more expressivity or less, you can go up and down the semantic ladder, so to speak, right? And the same is happening with the LTER community, mapping their vocabularies to other ontologies. It's a process that happens in the background, but the main thing is talk to one of us, any one of us, get your knowledge in there, and it will then be cross-linked, especially if you identify it in the Suite group, because this is where the activity for earth sciences is mostly concentrated, right? And then we'll coordinate this with life sciences and ecosystems and biosphere with the other communities we interface with.
Yeah.
And also sustainable development. So the United Nations has a UN SIF, Semantic Interoperability Framework, developing ontologies for their sustainable development goals and socioeconomic data. And we're working to align that with the OBO Foundry ontologies and then by proxy Suite through this work. And then once that's done, and there will be some demonstrator cases, I think, coming out in the next year to show how you can use these ontologies to cross-link sustainable development goal data streams with your Earth observation data streams. At least knowing where they are. We can't make data interoperable, but at least the knowledge is interoperable, and you can identify who has what. That's already a step in the right direction.
So there are, and this is something that we'll most likely be taking large care of on the development side. is there are labels you can utilize. So say, for example, Vardis, you had the example that Kai contributed, but you had a query about. Essentially, you can tag your issue, and you could tag your issue with question, right? And help wanted. And it basically indicates that this is not, we're not fully confident that things are ready to be contributed at this point in time. Let's hash it out. Also, I added tags for these foundational areas, the foundational concepts, the 9 concepts. I've added tags for these as well. But as I said, that's something that we can fix on our side. By the way, folks, out of just a bit of kind of side note here, we did actually make a release of Suite earlier today. So version 3.3.0 is literally released. It was John that had suggested that. So yeah. Okay. Vardis.
So I noticed in your suite diagram, biological is sort of covered in there, but I was just wondering whether sort of taxonomic hierarchies, like for genus, species, class, phylum, all of that, whether that kind of categorization, those concepts are already part of this ontology, or it's a separate ontology, or because those are very well mapped out,
I do know that species, I believe the BBC has a species ontology.
Well, the BBC does, and again,
Yep.
this is where that interface between the biomedical ontology, biological biomedical, and suite, that's where this key is happening.
Yeah.
Because with, for example, the ontologies that interoperate with ENVO, the gene ontology, we pull the taxonomy from NCBI, right? So we get their taxonomy, and that's then linked to all the genomic information that's present on those taxa. So you can actually just query what taxa have been observed in a certain environment or are identified with a particular habitat. Please get me their genomic information using the NCBI taxonomy identifier. So that's there. We use the NCBI taxonomy because it's linked to genomic information. There are others that are better curated for certain taxa, and in principle, they can be imported. There are working groups within TADWIG, the Biodiversity Information Standards community, that worry about that. But again, this is exactly where this interoperability comes into play. Ontologies broker between these different groups' knowledge bases. And if you identified that as a need, and put an issue tracker item there, that's something that we can then work on because there are resources available. We just need to know people need it so that we can prioritize work. Mesophication, what is this?
Yeah.
Zach, man. Sorry, mesophication. That's pretty funky.
Very nice. Very nice, Zach.
Yeah, no, I don't know how we're going to do that, but yeah, we can think of it. It's a process, right? That'd be the issues, I guess. Okay, so I think we're at the half hour, right?
I think so.
Okay. So then I'll hand over. I'll grab one of those and then show like this. So what I'm going to show is the process that we use in our cryosemantics working group to capture the knowledge in an ontology and then map it back to Suite, so that Suite has a direction, shall we say, and already has some access to technology from OBO that it can use in order to guide it. Because there's a lot of material in there, but we need guidance about which parts to develop, and that's what we're trying to do. So Zach, could you set me up as presenter? And we'll. All right, so this can get pretty trippy, and I'm not sure if it's a live demo, right? So I'm not sure if all of it will work. Some of it will, so any is too strong, but let's take a look at it. Zoom in, sorry, yes, just a moment. Okay, is that better?
Excellent.
Right, generic sample. Simon, I know that's Simon, Dr. Shorthair, and I know he's causing problems all over Ontospace, but no, it's true, that's a key. But let's take something a little bit more straightforward for this. No, don't be sorry, don't be sorry. So this is another thing you have to realize about ontologists, right? We constantly butt heads, and it sometimes looks like we argue a lot, but that's actually how we engineer a good layer, because that's where the knowledge interfaces have to happen. So it's a fun community to work in, and just don't be alarmed by our activities. Okay, let's do this quasi-stationary front. That looks pretty cool. What is it? It's a front. So now this is immediately where we get kind of like, this is then where an ontologist looks at this and says, oh, a quasi-stationary front has a synonym that's a stationary front. Now those can't be exact, I assume, but we'll work on that. Great, textual definition linked out to another resource over here. Let's just check out what that is. The meteorology glossary. Cool. Okay, good. We can work with that definition. This is also fun. Why is it called? Does anyone know why it's called meteorology? What it is the study of? Right. Well, things in the sky. So, or as the WMO classifies them, meteors. Anything in the sky is a meteor. A rainbow is a photometeor. A cloud is a hydrometeor, etc. Good fun. Anyway, we'll get into this a little bit. So, it's true. It's true. I couldn't believe I didn't know that. So great, and we have the attribution. We have the ORCID code, so that we can attribute Jim Beard. Yeah, where are you? Right over there. Great, good. All right, let's do this. So how we operate now? We're going to operate in Envo. So this is the Obo Foundry ontology for environments, and right now we're set up to be a bit more expressive than Suite. Yeah, I will. That's not really relevant to this. But what we're going to do, we're going to work on Envo. And Envo's fairly large, and it's aligned to these really abstract ontologies at the top, right? Buffo, which determines Aristotelian classes, et cetera, et cetera. As domain experts, you don't need to worry about that. We get right into it, and we look for what we have already in terms of fronts. So right now we have, where was that? Oceanic fronts, I believe. So let's just search for front. And we have some sorry? I know. We're gonna make yours, and that's the point, because this expert knowledge isn't in there. The closest thing we have is stuff about oceanic fronts. Over here you see, so if you hover over it, you'll get the URL to it. You can't really see that too well, but there it is. So you put that into your browser, it'll take you, or your machine, to that class. And you see where it's situated inside of how this ontology understands it. It's a kind of layer. It's like organized in a layer over here. In Obo and Foundry ontologies, we typically have textual definitions, which we work up from various sources. So that's the idea. It's been submitted by somebody over here with their ORCID. That's when they submitted it. And here you see what are called axioms. These link any class to other classes to say that layers have a laminar quality. Sounds kind of circular, but remember, machines have no concept of a lot of these things. So that's why we link it. And it inherits properties from up in the hierarchy. So the machine knows that this, in the case of Envo, environmental layers are part of an astronomical body, etc. Right? These are all inherited axioms from the top. So where do we go? We go to a special kind of layer called a cline. And a cline is a very thin layer in which some property changes very quickly, right? Over a short, in this case, vertical distance, which may be a problem for fronts because it can also be horizontal, correct? Yeah. So that's already something that we realized, we need to revise that based on your submission. This is already changing things a little bit. We have different kinds of clines, and a front is listed there. So what is that? It's just a narrow zone of enhanced horizontal gradients of some sort of water property. Does any of that, you can follow that kind of logic to create?
Yes, actually.
Oh, sorry, right.
That's an excellent point. For those in the room that want to literally follow this along, I'm viewing what Pierre's doing. The best way to do that is to go to the shed or sked. You can find it just 2019 ESIP summer sked, and absolutely. So once you're on that,
this is not a website. So this is us editing the actual ontology file in some software called Protégé. You'll see that there. If you wanted to see the actual ontology, we use a slightly different resolver. It's called OntoB, ontob.org, right? And this is where the Obo ontologies live. You can search for the environment ontology, and you can search for something like front. It will then take you to where this is front. This is the actual directional quality front. That's not what you mean. And those are anatomical fronts, like fronts of various organisms. So let's use the actual term here. And you can, it's not available. Maybe it's not even released yet.
Mm-hmm.
Anyway, if you wanted to look at the content in there, this is where you would look at it. But most of that's anatomical for the moment. Oh, there's a tidal mixing front, and here's a coastal upwelling front. So these are probably oceanic fronts. You click on one of those IRIs, as they're called, and it'll take you to a page where you can see some of the content, not all of it, but it tells you where you are, and it shows you how it's used, right? So that's a little excursus if you want to follow around. But this is now we're in an editor where we're going to change things a little bit. So we're clear that a front in your case is a layer, correct? So we can create this under something like a layer. Yeah, we're going to align it to the suite ontology, but first we got to express what you mean, and then we're going to draw from the OBO tech stack to do that and capture that knowledge, and then we'll link it to suite. So we're going to create something here, and this is as you said, what is it? A quasi-stationary front. Now, again, when we see something like that, whenever we get a single request, it often lets us know we need to engineer a whole bunch of other classes around it to weave it into the base model. But we'll concern ourselves only with this one for the moment. But what this sets us up to do is add things like a fully stationary front or a mobile front. We know that those other classes need to be created. As soon as I create this new class, it has its own IRI or new URL, which you can access it with. That won't be live until we make the next release, but we're getting started. So here we go. We have a class. It's Kai, you have a question?
Are you working on master, or did you make a new branch to do this edition?
No, I'm working on an existing branch, but cool. we won't get into that technicality for this demonstration. It's more here, right? So here's a quasi-stationary front. Now we're going to add some properties to this so that we know, again, or we teach the machines what we mean, right? Got a question, Zach? Oh, okay. So now we're going to add a definition. And again, that definition attribute it's identified by another ontology. So again, machine understands that what we're about to put in here is what humans call a definition. So here it is. This is the definition we're going to use. A front that is stationary or nearly so. So that's not a terribly useful definition as far as logics go. So we'll see if we can clean that up a little bit for the ontology. So let's grab that. I like the second part of this. So a front, which, this is just the Aristotelian form, is moving at a speed less than about 5 knots. Is that, I mean, again, according to this resource, that's what it is, right? That itself is a pretty clean definition. It has an identified threshold. So we could work with that initially. The rest of that material is sort of supplemental. So we put it into that thing called an RDFS comment. It's more like a clarifying statement that humans read. Machines wouldn't concern themselves too much with that. But this can be useful for us later on when we develop out that hierarchy, because then we can figure out how these things relate to each other. Okay, now we got that definition. Now it's important that we identify where that definition came from. So I copy that URL to the original source of the definition. I'm trying to move the GoToMeeting thing you can't see it, but it's there, okay. And so I'm gonna add an annotation on that definition to say that this came from somewhere. We use a property called database cross-reference. It's like a weak reference to something, showing that we did modify it. We could modify it. It's not a strict definition source, but if you want to know where we got that from, it comes from here. We're going to do the same with your ORCID, so that when people complain about it, they know that they can go to you and not to me. That's the main purpose, right? So in this case, the creator was automatically populated with my ORCID. We're just going to change that to your ORCID. And that's the nano crediting, right? So that we know that this came from, we're using the Dublin Core creator, and we know that this came from another person who's identified uniquely with their ORCID, right? We say,
yeah, exactly. So in this case, that's okay. He's in the room to approve that, but you're making some changes. Is that something you would do with all of these, is to say, well, I'm going to edit this slightly and then still give the credit back to the originator who might not have actually wanted that change?
No, we'd never do something. I mean, if it's somebody who submitted this, and we always talk on the issue, say, hey, look, this is what we did. Are you happy with it? And if they say yes, we close it. We'll close the issue, and then we've frozen that.
Okay,
right?
so that creator concept in this case represents the true author, if you like, or owner of the
Exactly.
final wording. Thank you.
Well, not the final. So the management. So it's not the final word on the class itself in Envo. It's like the final word on that contribution. Right.
Yeah, the problem is, won't the creator concept stick for all time to that contribution, even as it gets edited over time?
Yes, but the thing is, the edit history can be followed. So we know that there has been drift, and other people who have worked on it as contributors can also be added. So we know that there have been revisions, right? We have a question out there, Adam. Right.
One of the metadata, the fair metadata definitions refers to qualified references. I don't know if that's super relevant in this definition.
Yeah, no, it is in the sense that it says qualified references to other metadata, right?
Yeah.
This is a reference to other metadata about a human. It is qualified by DC creator, so a machine cannot qualify where this goes. So indeed, this ontology does follow those interoperability procedures. So it has that. And you can add other kinds of metadata in here. Like, for example, in Kai's definition, it was a DOI. It could be a data set. And if it has a unique identifier, we can qualify references to that metadata on this knowledge class.
Kai's definitions also had the components where it would say like it contains something else.
Yeah,
like
we're about to do that.
Okay,
we're
great.
about to do that. So what we've just done, we've created a term. We've given it a human readable definition. It has some machine readable logic around it. Like, machines know that this is a kind of layer, right? They know that it has a quality that's laminar. It's part of an astronomical body. So again, the machine knows all these things, but what else do we want the machine to know? So now I'm going to ask the submitter over here. So what else do we want them to know about quasi-stationary fronts? It's part of an atmosphere, right? It's atmospheric. An atmospheric of air. Okay. So then we can start adding what are called axioms. So we say that this is part of some atmosphere. Part of is a controlled relation. That's part of a relations ontology, that machines understand the logic of what is a part and what is not a part. And our atmosphere is already up there in Envo. So we'll say that it's a part of some atmosphere. And you said it separates two different masses of air. Meeting. Yeah, they're meeting. Okay. We can, as I'm not entirely sure, I'd have to think about that a little bit, but it would look something like this. We would say then it's adjacent to some mass, and I think we have different kinds of masses. I'm not sure we have mass of air. Interesting. Yes, it is. That's a surface layer or a boundary layer. We can see if we can move it there. But that's essentially how we do it. So let's see, boundary layers are usually between some sort of solid. So we have boundary layer. There's a layer of fluid, so that's air or water, in the immediate vicinity of a bounding surface. No, but that's more like a solid surface. Again, it's adjacent to a surface layer, so we wouldn't really use that. We'll think about that. So I'm going to add that in. So right now, I'm not going to be able to do that in this short demonstration. I'll think about that, but what I will do, I add that to an editor note telling me to think about this. So basically, just let me know what you want captured. And again, we're doing this live. But in the issue tracker, we'd be having this conversation over the tracker. I'd be like posting questions to you. It's like, how best should I define it? So how about we just go verbatim? So this front separates two distinct masses of air, right? Is that sufficient? What else do you really need to know?
Here's the definition of front. From the same.
All right, yeah, let's do that. Okay,
so
no,
the
this is
definition
good.
of front here, in meteorology, generally the interface or transition zone between two air masses of different density.
Cool. So that's what we need to do. We need to create some context here.
Yeah.
So we've created a class called front, and now you see that it's put in an identifier because there's another front somewhere in the ontology, which is the quality, the front of an organism. So that's just letting us know that there's something with the same label. There we go. So now we have quasi-stationary front as a kind of front. And let's do that. Was that the same resource you got the definition from?
Yes, I'm about to add it to the issue.
Great. Redirected from stationary front. This doesn't tell us. Okay. So we'd have to search for it as opposed to discover it with linkage structures. That's it.
Right, it's a vocabulary, but it has no linking.
Yeah, same idea. We're just very quickly going to work through it. We're adding a definition. Oops, sorry. I'm just creating a dummy definition for the moment. And then we're adding the reference to that resource, same way we did before. And this is a part of the engineering thing, right? That we make sure we know where stuff came from, even if we modify it. It lets people go there. It's interesting because many of these things tend to change over time, but we have a timestamp on the creation of the class, so we know where it came from. Okay, definition, we put that there. So this is interesting. It says in meteorology. The interface, so we're going to adapt that to an Aristotelian definition, a layer which acts as an interface or transition zone between two air masses of different density. Okay, so actually what the label to be verbose is, we clarify that as atmospheric front, because that's what the definition is talking about. It's talking about atmospheric fronts and not other kinds of fronts. That's fine. Now we know what it is. And then we can add those relationships. So we can say, okay, this is part of an atmosphere. And then if it's part of an atmosphere, this links to all the semantics that we already engineered into atmospheres. Hop over to atmosphere, a layer of gases surrounding a material body of sufficient mass that it's held in place by gravity of the body. And it knows that atmospheres are composed primarily of some sort of gas. It doesn't have to be air, but that's what the axioms do. So that's the atmosphere. We have an atmospheric layer. Where did we go? There's atmospheric front. Good. Right. We have that. Now we no longer need this axiom here that it's part of some atmosphere because it's inherited from above. There it is. It knows. It already gets that knowledge in there. Cool. So that's it. We'd add more axioms as we need them. So this idea in the editor note that we captured separates two distinct masses of air in an atmosphere. We then figure out with all the relations that we have over here, we have a bunch of relations that we use to help the machine understand what these things are, like connects, contains, depends on, etc. We'd use that to then encode this. I won't do this now, and that's beyond the scope of this, but that's what we're going to do with whatever you put in those requests. We'll engineer some semantics around it. To give you a demonstration of where it would go, if you take a look at some of the existing things, like let's say, the example I gave earlier was the volcanic eruption. So we can take a look at that. Volcanic eruption, which is a process. So now we're going to hop over to the process hierarchy. There it is. And here's all those axioms. It has output some carbon dioxide, sulfur dioxide, water vapor. It happens in the planetary crust, etc. And as soon as we touch that, that's another ontology, CHEBI, the chemical ontology. So we leverage all the work they did in chemical knowledge modeling. I go there, and so the ontology knows what carbon monoxide is. It knows that it has parts that are carbon compounds. It knows where that sits inside the table, etc. The same is true for the taxonomy. That was a question earlier, right? So for example, if we have a reef, like a marine reef, I think we have some mussel reefs. There are mussels around here. So there we go. This is actually from CMEX, the federal standard for coastal and marine ecosystem classification. The class was the Bathymodulos dominated oceanic mussel bed. So again, we understand that it's a mussel bed, it's a marine faunal bed, so it occurs in an ocean, etc., etc. It's submerged. And then we get here, we link back to the original CMEX class that this came from. And it says this ecosystem, or this bed, has parts, some ecological community, composed primarily of some Bathymodulos. We hop over there, that's the taxonomy from NCBI taxonomy. So again, if you queried, get me any ecosystem that has bilateria as a part, you would get that result because the linkage structure would take you there. That's why we bother with all of this stuff, to help machines understand where it goes. So that's the expressiveness. I won't go any further on that because we only have 10 minutes left. But let's hop over to that quasi. Is this done in Suite? You saw this in Suite? Okay, great. So we have the quasi-stationary front. Okay, so let's take atmospheric front because then we can probably find where this goes. So atmospheric front, we're going to then hop over to Suite And this is what we do. Again, you don't have to worry too much about it. You've given us the knowledge guidance to actually activate and work on this and figure out what needs to be done. So we're in Suite, and we're going to do front, right? There it is, so fin Atmo front, right? That one? Yep. Yeah. So we get the IRI, so that unique identifier. Like if we put that into your browser, it would take you to, oh, it's not found. Is it broken? Or maybe I'm not using it correctly. Chuck, what's happening? Okay. It should work. Okay. I delete that? Yeah, good. Yeah, so that IRI would take you to what Suite has for front. And again, there's not much there in terms of semantics, but it's there and it's in the thing. So what we're going to do is link the two, and then what we've engineered in Envo with its technology stack that we inherited from the biological community, because they've been working on this for a while, we're going to transfer that to the Suite environment so that Earth Science can benefit from that stuff. So then we got the IRI here, or the link, and I'm going to add that over here as for the moment, we add it as a database cross-reference, and we link it to Suite. So now we have something that's able to express a little bit more of what you wanted to transfer. We've stabilized that. We give it an IRI, and we bind it to Suite. So then when we have the capacity, that can be moved into the whole Suite ecosystem and then benefit Earth Science. In the meantime, the next release of Envo, it's already out there, and it can be used, and it's linked back to Suite. So this is how we operate. Anything you do, that's what you just did in terms of transferring some knowledge to us, has triggered that and changed the semantic layer. We've reshaped it. Yep. So we're
the landing page for the.
So Lewis asked us to go back here, and he's
yes, perfect. Can you zoom in, please? And go to this OWL version info.
What are you looking at? Version info.
Perfect. This OWL version info this morning would have been 3.2.0. It's 3.3.0. The nice thing about this is that it's automatically updated. We through this process of knowledge gathering and contribution, there are systems which serve this out to anybody that wishes to use it, and we have an entire workflow which is streamlined to ensure that any contributions are literally flushed out should there be quality contributions and they make it into the knowledge source and they're flushed out. So I just wanted to point that out there, that it doesn't, and I'm not criticizing when I say this. It's not CF conventions where it takes 2.5 years to get a release type thing. We're rapid.
Yeah, we try to be more nimble, but at the same time, we recognize the need for agencies like OGC and others, which have a more, let's say, rigorous process. Right. But in the meantime, work needs to get done. And we hope to feed this stuff forward towards them so that then they have something where the community has already come together, built a consensus, and coded it. It will make their work that much faster.
Yeah, thank you.
All right, so that's a preview. I mean, we're almost out of time, so maybe we just take questions there. But what's going to happen next? We run something called a reasoner that checks the whole logical consistency. You see, it's automatically classified atmospheric front as an atmospheric layer because we've set up logic that says any layer that's part of an atmosphere, automatically classify it here, please, right? So that's how it works. And then that saves us, number one, it checks that everything's logically consistent. Secondly, we don't have to put in all of the cross dependencies. If we engineer the logic right, the machine does that for us, and it can actually help us with discovery. Linkages that we never saw can be then generated, because there's a lot of content, as you see. There's a lot of content that we use to build these sort of things. All right, so I hope this has given you a preview of what we're up to in the Semantic Tech community, and also how easy it is for you to push some knowledge about what you care about. Just post on the tracker, and it triggers us to look at that section of this huge collection of terms in Suite and Envo and improve it. So now I'm going to go back, look at that submission, restructure the front hierarchy, and make sure it serves both the atmospheric and the oceanic community, right? And that was one issue, is able to do that and change the semantic layer. Yeah. So yeah, please go ahead, tell your friends.
Out of curiosity, folks, is anybody, thinking forward, does anybody plan to be at the fall AGU meeting that would be potentially interested in attending a half-day workshop? We've got one person in the room, maybe a couple of others, a few others. Okay, well, I think it's definitely worthwhile, trying to put something on. What about this meeting, Ocean Sciences meeting coming up, the AGU Ocean Sciences meeting in San Diego? Is anybody planning on being there? 1, 2. Okay. Right, thank you very much.
Before we conclude, Andrea, is she here or did she leave?
She just left.
Oh, she just left. Okay, so I'll have to give a little shout out. So tomorrow there's a conceptual modeling session run by Andrea Thummer and others. And what they're trying to do is very similar to this, just without, let's say, the technological overhead. So you can always post issues here, but let's say you're not quite sure and you want to model some concepts around it and prepare yourself with a community. They're trying to set that up for their community and maybe invite more experts to do so. And it's more about a little bit of training in how to go about conceptual modeling in a consistent way. So check that out too. It'll all feeds together. We'll all be talking to each other and trying to get knowledge to flow into human knowledge to flow into the data science and machine intelligence realm to serve applications in the future. But thank you very much for your contributions. Keep them coming. And yeah, talk to us if you want any more stuff in there, or if you'd like to know more about how to actually use the stuff that will be pushed into the semantic layer.
Okay.
All right, Lewis, final words?
I think, yeah, we're ready to conclude, folks. Just to say that we did have remote participants for the session as well. So thank you for kind of sticking with us for the microphone. Thank you for dialing in to all the remote participants as well. As Pierre had mentioned, session tomorrow. So please feel free to come along to that. Chuck, I think you're just standing up. Right, okay. Right, folks, that's it. Thank you very much.
Great.